Welcome to the Merlin and Metro News Network. Today's program covers the passenger door and latching system. This program will cover the bayonet latching system used in current production. Some of you may work on older aircraft that use the click-clack latching system. Click-clacks, their operation and maintenance, are covered in the cargo door tape. This information is also relevant to cabin doors equipped with click-clacks as well. Now let's roll our first program.
The Merlin and Metro cabin door serves dual functions. It of course is used to close the aircraft cabin and seal in pressurization. It is also used as an entry device for passengers and crew. It is designed to take two different types of loads, pressurization and flight loads, which generally tend to push out on the door, and enplaning loads, which are more localized on the individual steps. The door itself is constructed in conventional fashion. An outer series of frames is supported by internal ribs and braces. In addition to providing structural strength for the door, these items also serve as mounting points for the door latching mechanisms. A one-piece outer skin is riveted to the door structure. This skin is trimmed to extend past the door framework to create a rest for an inflatable rubber door seal. Attached to the completed door structure is the door step assembly. This unit is designed to receive localized passenger enplanement loads and distribute them evenly throughout the door structure. The entire step assembly is removable for easy access to the door mechanisms. The steps themselves are removable and are made from aluminum honeycomb. Latching the door into the aircraft structure is accomplished through pins or bayonets that extend into the aircraft door frame. There are 9 of these bayonets located around the door. Only 7 of them perform the actual latching function. The other 2 are used to help align the door prior to the engagement of the load-carrying bayonets. 2 handles, one inside and one outside, operate the bayonets. Each of these handles is connected to a common shaft that rotates a bell crank attached to the shaft. Push-pull rods transmit this motion outward to 2 additional sets of bell cranks. Each of these bell cranks is attached to an additional set of push-pull rods that are connected to the bayonets. The topmost bayonet latch is actuated through a double set of bell cranks that also operate the aligning bayonets. This mechanism has been designed to push the aligning bayonets into the door opening prior to the extension of the remaining bayonet latches. These aligning bayonets are designed to complete the aligning of the door as necessary, so that the load-carrying bayonets can be easily engaged. All of these mechanisms are designed to move to an over-center position when the door handle has reached the fully closed position. This makes the door locking non-reversible without rotating the handle. An additional tube and spring assembly connected directly to the handle are used to stop the handle itself from moving without intentional external force being applied. There is also a safety diaphragm installed that will lock the door handle when the aircraft is pressurized. Within the assembly, a rubber diaphragm is acted upon by cabin pressure. As pressure causes it to deflect, it moves a latching hook into a position that locks the external door handle operating mechanism. This locking feature prevents the door from being opened with the cabin pressurized, whether in flight or during ground pressurized operations, such as during testing and maintenance.
The door seal valve and door seal play an important part in successful door operation. If the door seal is inflating before the door latching process is completed, or not deflated before door unlatching begins, trouble is sure to result. Even with the largest person you can find at the handle, you will not close the door with the seal inflated. Make sure the door seal valve is properly rigged and functioning. If the door seal valve is freezing in the wintertime, the door seal pressure dryer and filter had probably not been serviced often enough. Now let's return for the conclusion of the program.
The handle bell crank also contacts and opens the door seal inflation valve. This valve will allow 18 psi air from the de-ice pressure regulator to be routed to the door seal. When the door seal inflates, it will seal the door against a loss of pressurization. The geometry of the bell crank that actuates the valve has been designed so that when closing the door seal valve will not be actuated until the latching mechanism is near fully engaged. When the handle is moved to the open position, the geometry is such that the door seal valve will be actuated closed, which removes pressure from the seal and also dumps any trap door seal pressure prior to the retraction of the latching mechanism. This is so that the latching or unlatching of the door is always accomplished with the door seal deflated. If the seal were not deflated prior to closing, the door is not likely to be closed, as the seal will prevent the door from fully going into the opening. Worse yet, trying to force the door closed could damage the seal, because when inflated, the door seal will be larger than the gap between the door and the door opening. The door opening in the fuselage contains the fittings to receive the bayonets, a warning system to inform the pilot of the door status, either fully closed or unsafe, an attaching point for the door hinge, and attaching points for the passenger assist chains. On some aircraft, the door snubber is also attached to the fuselage door frame, while on some, the snubber is attached to a separate handle on the pilot's bulkhead. The fittings, or receptacles, installed in the door opening are cast assemblies that mount securely into the aircraft structure. Each receptacle contains an eccentric bushing that may be rotated to adjust the alignment of the bayonet and receptacle. These bushings are available with different amounts of eccentricity for use in correcting alignment problems. A locking plate is used to prevent future rotation of the bushing after it has been properly positioned. This plate is secured through the receptacle face plate screws. The fittings that receive the aligning bayonets are fixed installations and do not incorporate eccentric bushings. A micro switch is installed within each latching receptacle assembly that will be actuated when there is full engagement of the bayonet. These 7 micro switches are connected to a red cabin door warning light installed in the annunciator panel. The switches are wired in parallel, and all must be fully made by each one's respective bayonet before the light will extinguish. Any single unmade switch will cause the light to illuminate. The position of the bayonets can also be visually inspected through clear plastic inspection windows in the door. Green and white markings on the bayonet are used as indicators to determine its position relative to the amount of engagement in the receptacle. The door hinge plays an important part in door operation. It carries part of the load imposed on the door in flight and most of the load imposed on the door during ground operations. The fuselage half is an L-shaped aluminum unit, while the door half is a flat stainless steel unit. The life of the hinge can be greatly influenced by maintenance activities on the door. Additionally, since the hinge is a fixed point, it, along with the aligning bayonets, are the critical factors involved in aligning the door into position. In short, if the aligning bayonets engage properly, but the hinge is warped, cracked, or worn to the point where it is not maintaining its rigidity as a fixed point, then the door will be extremely difficult to fully close and lock. 2 assist chains and stanchions are provided to allow easier enplanement by passengers. The spring-loaded stanchions are used to position the chains for easy grasping by the passengers. The chains themselves are covered with a fabric or vinyl covering for appearance and functionality. During door opening and closing, the path of these chains must be monitored to ensure that they do not become entangled in the door mechanisms or caught between the door and the door opening. A snubber is installed to assist in opening and closing the door. This device uses a fluid-filled snubber assisted by a spring. When the door is opened and begins traveling downward, the fluid-containing snubber helps to cushion the weight of the door by restricting the flow of fluid through the snubber as it extends. The spring attached to the snubber is also being stretched during this time. On door closing, the force of the spring trying to retract now assists in lifting the weight of the door. The internal snubber is designed to only snub in one direction, so it does not impart any resistance to the door being closed. There is a customer option to allow 2 door snubbers to be installed, one on the forward side and one on the aft side.
The passenger door is one of the most operator-affected items on the aircraft. The personnel that routinely open and close the passenger door can save you a lot of headaches or make your life miserable. There is an incredible correlation between door problems and operators. Some operators have few problems, while others have many. In almost every case, it can be traced back to the techniques used to open and close the door. Lots of tender loving care during door operation will save you many hours of maintenance. Until our next program, good flying and good maintenance.